So students, here in this class we are going to study the SCR triggering circuit using UJT. So it is the most effective way of triggering the SCR with the help of UJT. So UJT, unijunction transistor. It consists of a unijunction which is formed between the emitter and which is formed between the emitter. This is the unijunction which is formed between the terminals emitter and this is the terminal B2. So a junction is formed between the emitter and base 2, and we have a voltage this across this junction, that is VD. So we have the three terminals of the UJT are, this is emitter, this is base 2, and this is base 1. So we are applying voltage between this terminals. So this voltage is, we call it as, because it is applying to the two terminals, so it is called as VBB. So this resistance R2 is the resistance which present in the base 2 region, that is from this region to this region, this part to this part. And here one more resistance we have, that is R1, which is the resistance present between the base 1 region, from the emitter to base 1 region, that is R1. So R1 is the resistance from emitter to base 1, and R2 is the resistance from the emitter to base 2. So when this R1 is so here the resistance R1 is almost equal to R2. So that is the intrinsic stand of material, that is distributed equally between the from emitter to base 1, which is equal to the emitter to base 2. So therefore the resistance RB1 is the resistance present in the base 1 region is almost equal to base 2 region, base 2. So R1 is equal to R2. So the voltage which applied, we are applying voltage between these terminals, base 1 and base 2, so it is called as VBB. So VBB is distributed equally between the resistors R1 and R2. VBB is distributed equally between resistors R1 and R2. So when VBB is distributed equally between R1 and R2, so if we are giving a 10 volts, so a 5 volts is present across R1, and another 5 volts is present across R2. Okay, so that is the volt. So this resistor R1 and R2 forming a volt, along with this VBB, it is forming a voltage divider circuit. So VBB base 1 resistance R1 and base 2 resistance R2 forming a voltage divider circuit. So let us so this is on the when we are giving the supply VBB, so this voltage is distributed, this VBB is divided equally between the resistors R1 and R2. And on the other side, in the input side, we have the emitter which is connected to a time constant circuit R1 and C. Okay, so when we give the supply, let us assume a 10 volts is given, 10 volt supply is given. When we switch on the power supply, so 5 volts is formed between at the emitter to base 1 region, and a 5 volts is formed between emitter to base 2 region. So but the voltage at the emitter terminal is 0. Why? Because the voltage, emitter voltage is nothing but equal to the capacitor voltage. Capacitor is charging from 0. Initially it is charging from 0. So input, at the input side we have a voltage which is equal to 0 capacitor voltage, that is the emitter voltage is 0. Capacitor voltage is nothing but equal to because capacitor is connected to the emitter terminals and capacitor is charging from initially it is charging from 0, so emitter voltage is 0. So initially the UJT is in the emitter input terminal of the UJT is at 0 potential, and the output side we have a voltage that is that when the supply is switched on, we have a voltage that is existing that is half of the supply voltage is existing on the output side. So this will keep the UJT in the off position. Okay, so here on the output side, total in the output side we have a voltage which is equal to actually the output we have a voltage which is equal to the peak point voltage, we call it as peak point voltage, which is equal to VD and plus VR2. So VB plus, so VP, it is when initially when the power is switched on, we have and the output side we have a voltage that exists, output side we have a voltage that exists which is equal to VP, which is the sum of VR2 plus VD. So this is the VD, which is the junction is formed, so we have a cut-in voltage that is equal to VD between emitter and base 2. So this VD plus VR2 is nothing but equal to VP, which is the voltage that is existing between emitter and base 2. So this will keep the UJT in the off condition, because emitter is 0, emitter is VE is 0 initially. So input side we have a 0 voltage and the output side we have voltage VP. So this will keep the UJT in the off condition, So now the capacitor is gradually charging when the supply is given. So we have a voltage VP on the output side which is and the emitter is at 0, so UJT is in the off position, but the capacitor is charging gradually. From 0. See, the capacitor is charging gradually from 0. So voltage of the capacitor is nothing but to emitter voltage which is increasing gradually from 0 to some 0. Okay, so in the process it will reach a voltage which is equal to VP. So when the capacitor voltage reaches the value which is equal to VP, then the emitter base 2 junction is forward biased and the UJT starts conducting the current. When UJT is conducting, now the capacitor start discharging. When UJT is conducting now, so it happens when the emitter voltage becomes equal to capacitor voltage. This is the capacitor voltage which is equal to the emitter voltage which reaches equal to VP. So when in this at this point the UJT is conducting. So when the UJT is conducting, now the capacitor start discharging towards 0. So when the capacitor is discharging, when the UJT is conducting, the capacitor start discharging and the capacitor voltage falls towards 0. In the process, when the capacitor voltage reaches, in the process of discharging, when the capacitor voltage reaches a value which is equal to valley point voltage of the UJT, then the UJT will become again, the UJT again comes the UJT again the UJT again comes into off position. UJT will become off. So UJT will become off, this will become off. So again, so this path will be closed, no current flowing through. And now what happens, again the current flowing through this input side will start charging the capacitor from 0, from sorry, not from 0, from the value of VV, from the value of VV. Again it starts towards increasing the VP value. So this cycle will repeat, so producing when the UJT is conducting, it will in a short duration of time, that is when the capacitor is discharging. So UJT is conducting a period in the discharging period of the, so when UJT is conducting, so it acts as a short circuit path for the capacitor. So the current flowing through the resistor will produce a pulses. So these pulses will act as gate triggering pulses to the SCR, that are applied to the SCR. So the SCR will start conducting the current. So this is the way how we are giving pulses, positive pulses. A sudden a short duration of pulses are acting as triggering pulses to the SCR. So the SCR will start conducting the current after receiving these gate pulses coming from the emitter base to terminal of the UJT. Okay, so this is how the SCR is getting the triggering pulses from the UJT. Okay, so now